Good morning children. In today's class we are going to do problems based on statistical quality control. In the given problem with x bar and r for various samples, say 1 to 10, let us find out x double bar and r bar. To find the control limits for x bar chart and R range chart. Having found out UCL, CL, LCL, we can check if all the values of the samples fall within the limits. Even if one value falls outside the limit, we will immediately conclude that the process is not in control. Exercise 9.3, question number 14. A machine is set to deliver packets of a given weight. 10 samples of size 5 each were recorded and given below. Sample number 1 to 10. X bar and R are calculated for samples of size 5. When they give you samples of size 5, they will give you what is A2, D3, D4 values. Suppose if it is not given, we will refer to the table given in our textbook and identify the values A2, D3, D4. In this question, n is equal to 5, A2, D3, D4 are given. Find out x double bar, that is average of x bar. Add all the x bar values, divide by the number of samples. 15 plus 17 plus 15 plus 18 plus 17 plus 14 plus 18 plus 15 plus 17 plus 16 gives us 162. 10 samples are given, so divide by 10. X double bar is 16.2. R bar, add all the range values 7, 7, 4, 9, 8, 7, 12, 4, 11, 5. Adding all together we get 74. Divide by 10, we get 7.4. What is the control limit for X bar chart? We have to find out UCL, CL and LCL. Remember the formula. UCL, x double bar plus A2 R bar. LCL, x double bar minus A2 R bar. And CL is only x double bar. What is x double bar? As we calculate, it is 16.2. X double bar plus A2 given in the question 0.58 into R bar is 7.4. Multiply these two, add with 16.2 and find out the answer. We get 20.492. LCL x double bar 16.2 minus 0.58 into R bar is 7.4. Multiply these two. 0.58 into 7.4. Whatever answer you get, subtract from 16.2. Your answer is 11.908. So we know what is LCL, CL and UCL. This is for X bar chart. Now we will proceed on to range chart. UCL, D4 R bar. D4 is 2.115. R bar is 7.4. Multiply and find out the answer. 15.651. CL is only R bar, which is 7.4. LCL is D3 R bar. D3 0, R bar 7.4. 0 into any number, my answer is 0. As we have got the three different values, check whether X bar falls inside the control limits. If the question is only to find UCL, CL, LCL values, just stop the answer with this. But if they ask you to construct X bar and R chart, we need to draw UCL. It is 20.492. So 20.5. We can mark 20.5. It will be somewhere here. So this is 20.492. Draw a line to mention 20.492. LCL 11.908. It will be here. So we have marked 11.908. CL is 16.2. It will be somewhere here. So this is 16.2. We have UCL, CL, LCL. We can also denote the limit values from here. Now, let us plot the values from the given data. Sample 1 is 15. So, 1 to 10 samples let us mark down. And the X bar values are ranging from 14 to 18. So, we can mark 1 to 20 along y-axis, calling them as average weight as in the question. Now, we will mark the points. 1, it is 15. 1, 15. 2, 17. 2, 17. 3, 15. 3, 15. 4, 18. 5, 17. 6, 14. 7, 18. 8, 15. 9, 17. 10, 16. As we have plotted the points, we can check. All the points are falling between LCL and UCL. So, X bar chart, we can conclude the process is in control. But that is not the final conclusion. We need to check R chart also. As we come up to R chart, the control limits, again we have marked sample 1 to 10 here. Range of weights, here we have started from 4 to 12 are there. So we will mark from 1 to 20 as before. This we term as R chart. Along x-axis write sample, along y-axis write range of weights. Now we shall draw UCL, CL and LCL. UCL 15.651. 15.651. So it will be somewhere here. 15.651. LCL is 0. So this line we call LCL. CL is 7.4. So it is here 7.4. Let us draw the 3 lines to show LCL, CL and UCL. Now we shall plot the points. Sample number 1, under R I have 7. So 1, 7. 2, 7. 3, 4. 4, 9. 5, 8. 6, 7. 7, 12. 8, 4. 9, 11. 10, 5. As we have plotted the points, we can check the points are between LCL and UCL. So, as we compare both the charts, we can decide all the points given are in between LCL and UCL in both the charts. So, we can conclude the process is in control. If they ask you to calculate the values alone, find out UCL, CL, LCL, and you can check manually even without drawing the charts. Just by looking at the points, we can check whether they fall within UCL and LCL, and I can conclude also. So according to the question and based on marks, you can answer the problem. Question number 15. 10 samples of size 5 are drawn at regular intervals. Sample number 1 to 10 given. X bar values are given. R is given. When n is 5, this 5 only we mention here. They have given A2, D3, D4 values too. X double bar is sigma X bar by number of samples. Add all the values, divide by 10 because there are 10 samples. 462 by 10 gives us 46.2. R bar, add all R values, divide by 10. 7, 5, 7, 9, 5, 8, 8, 6, 7, 6. Add the values. 68 by 10 gives us 6.8. Control limits for X bar chart. CL, X double bar, which is 46.2. UCL, X double bar plus A2 R bar. 46.2 plus A2 is 0.58 into R bar is 6.8. Multiply the two, add with 46.2. We get 50.144. LCL, X double bar, that is 46.2 minus A2 R bar. A2 is 0.58, R bar is 6.8. Multiply, subtract from 46.2. We get 42.256. So this question tells us LCL is 42.2, UCL is 50.144. Cross check the values. X bar values, check whether any number is above 50. We have 53, 51. So these numbers fall beyond UCL. 42.256. I have some numbers falling below 39. 239s are there. So these values fall below. So some values fall below, some values fall above. So we will say the process is not under control. Proceeding to find control limits for range chart. CL is R bar, that is 6.8. UCL D4 R bar. D4 2.115 into R bar 6.8. As we multiply, we get 14.382. D3 is 0. R bar is 6.8. As we multiply, we get 0. Check in range values. We need to know 0 to 14.382. All the values in range are between 0 and 14.382. But certain values of X bar fall outside. 2 are below, 2 are above. So altogether, 4 values of X bar fall beyond the control limits. Tell us the process is not in control. Question number 17. Calculate the values for control limits for mean and range chart and determine whether the process is in control. Samples of size 5 each. Given sample number 1 to 10, mean values and range values. Let us find out x double bar. It is sigma x bar by number of samples. So 10 samples, so we divide by 10, add all these values. We get 106.6 by 10, that is 10.66. R bar, sigma r, total all the range values divide by 10 gives us 6.3. Control limits for x bar chart, we have the formula CL is x double bar, that is 10.66. UCL 10.66 plus A2 value 0.58, R bar 6.3. As we multiply and add, we get 14.314. LCL is x double bar minus A2 R bar. 10.66 minus 0.58 into 6.3. Multiply and subtract from 10.66. We get 7.006. Check the values. UCL is 14.3. LCL is 7.0. When I check the mean values, no value is below 7.0 and no value is above 14.3. So we will say, as long as X bar chart is concerned, the process is in control. Let us proceed on to R chart. CL is R bar, that is 6.3. UCL, it is D4 R bar, 2.115 into 6.3. 13.3182. LCL is D3 R bar. D3 0, R bar is 6.3. 0 into 6.3 is 0 only. Let us check. LCL 0, UCL 13.3. Range values. No value is below 0. Range values. No value is above 13.3. All the values are below 13.3 only. So, in both the charts, we can conclude all the points fall within the control limits. Hence, the process is in control. Question number 19. X bar and R of 10 samples are given. Size 4. So A2, D3, D4 will change because the size is 4 now. X double bar. How to calculate? Add all X bar, divide by 10. We get 301 by 10, that is 30.1. R bar. Add all the range values. 39, 10, 39, 17, 12, 25, 21, 23, 15. As we add, we get 201. Dividing by 10 gives us 20.1. Now, the control limits for X bar chart. As we know, CL is X double bar, that is 30.1. UCL is X double bar plus A2. It is 0.729. R bar is 20.1. We get UCL as 44.753. LCL is X double bar minus A2 R bar. As we substitute the values, we get 15.4471. Check the values of X bar. LCL 15.4. There is a value which is below 15.4 and UCL is 44.7. There is a value which is above UCL. So, as we consider X bar chart, we can say the process is not in control. Proceeding to R chart. CL is R bar, that is 20.1. UCL is D4 R bar 2.282 into 20.1 gives us, we get 45.8682. We get 45.8682. LCL D3 R bar 0 into R bar is 20.1, that is 0. Checking R values. Below 0 there is no value. Above 45.87 also there is no value. In our chart it is not a problem, but in X bar chart one value is below 15.4 and one value is above 44.75. Therefore, we will conclude, since 2 points fall beyond the control limit in X bar chart, the process is not in control. The question is to construct the control chart. So we need to draw X bar chart and R chart in the graph. As we try to plot the points in X bar chart, CL is 30.1. So it will be here. This is CL. UCL is 44.753 here, and LCL 15.4. So it will be here. So let us draw the lines. Let us plot the points. 129, 129, 226, 337, 434, 514, 645, 739, 820, 934, 1023. Just join the points to check whether they all fall within the limits. As of now, here a point is below LCL, here a point is above UCL. So we will declare the process is not in control. Just draw the lines connecting the points to show that 2 points are beyond the limits. Let us proceed on to R chart. For R chart, CL is 20.1. Here it is. UCL 45.8. Here it is. LCL 0. Here it is. Let us draw the lines. Let us plot the points. 139, 210, 339, 417, 512, 620, 75, 821, 923 and 1015. As we have plotted, let us join the lines. The lines show that all the points in R are between UCL and LCL. But some points in X bar chart are beyond the limits. So we will still say the process is not in control.